Greeting to all. My name is Ashish Narayan Murthy. ID number S11066225. I am taking one teaching subject, that is technical drawing. This video is recorded on 11th October 2021. The topic that I am going to discuss today is on centroid. In our previous class on the same topic, we had defined centroid, calculated the area of the quadrilaterals, and also drawn the combined geometrical shape. Today's learning outcome, by the end of this lesson you will be able to find the centroid using ratio of areas or moment. Before that, let me again emphasize on the importance of learning centroid. Centroid is important where you have to design any mechanical structure. You are our future engineers. It is important to know how to deal with structural analysis, the forces acting on each members of structures. In order to have stability, centroid should be located carefully. Okay, I have one example. I'll discuss how to find the ratio of areas using one example. Before that, centroid by moment. This moment allows the use of calculation, graphical drawings and ratios to find the centroid of complex shape. To find the centroid of complex shape, there are few steps. First one, divide the complex shapes into simple shapes. Locate the centroid of the simple shape. Calculate the area of the simple shapes to determine the ratio of the area. Divide the distance between the centroid according to the ratio. And the last step is the centroid is located closer to the shape with greater area. Okay, you can see example 1 here. Okay, before we attempt this example 1, okay, let me ask you some few questions regarding how to find the area of some common shape. Can anyone tell me how to find the area of a rectangle and how to locate the centroid of a rectangle? Okay, some of the shapes that you need to know how to find centroid and how to find the area are square, rectangle, triangle, circle and trapezium. Okay, looking at this example here. Okay, you are given a composite geometrical shape of a trapezium and rectangle. You are required to locate the centroid by using ratio method. Example 1, given a composite geometrical shape of a trapezium and a rectangle, you are required to locate the centroid by using the ratio method. The first thing you will do here is divide the complex shapes into simple shapes. Okay, in this question, a rectangle and a trapezium is already a simple shape, so we don't need to further divide this. Okay, next then we will locate the centroid of the simple shape. To get the centroid of a rectangle, we will just draw any two diagonal. So this is your center for rectangle. For trapezium, we need to get the centroid for trapezium. We'll bisect this line here. To get the center of that. So the center of this line is here. Next, you have to find the center of this line. I'm bisecting that line to get the center. So center for this line is here and center for this line is here. Lightly join this line. Next, extend this line and extend this line this way on your left. Take this length and mark on your right. Take this length and mark on your left. Then you join these 2 points. The place where this line and this line intersect is your centroid for trapezium. Next, we have to calculate the area of these two shapes. The area of A is a rectangle, area of B is a trapezium. So to get the area of A, rectangle is length times width. So length is 5, width is 4, so area is 20. Okay, we can say 20 unit. The area of B is a trapezium. The area for trapezium is half A plus B times height. A can be this one or either this one. So in this question I will use A, this one. So the length of that one is, that line is 6, this line 4, then the height is 2. So the area for trapezium is 10. In simplified ratio form of area A is to B, 20 is to 10, simplified 2 is to 1. Next, you will join the centroid of A and the centroid of B together. Centroid of A is here, centroid of B is here. Join this using a straight line and divide this line into 3 parts. And divide in a ratio 2 is to 1. Your centroid will be located closer to the area which has a bigger area. Your centroid will be located to the shapes which has a bigger area. So in this case, area I is a bigger area. So ratio 2 is to 1. Your centroid is here. You can label this at C. I am giving you one exercise on centroid. You have this question in your workbook. Everyone should have a workbook each. Those who do not have a workbook can draw this question on paper and try to attempt. When you finish with this exercise, try to send me a snapshot. Anything which is not clear in this video or in this concept, on this topic, you can ask me in our next Zoom class, which we are going to have next week. Thank you.